Hello, everybody. Today we'll be starting with part two of rational numbers. Before we start with part two, I would like to reassure that you have done the homework which was given in part one of the chapter. Now, let us proceed with part two. The first topic that we have to do in this part is representation of rational numbers on the number line. So the number line for rational numbers will extend from minus infinity to infinity. As you know that there are negative rational numbers as well as positive rational numbers. Now we look at some examples of the number line. The first one, the easy one, in which you have to show the rational numbers 1 by 2 and minus 1 by 2. So if you look at the number line, there is 0 in the middle, and then the interval 0 to 1 is divided into exactly two equal parts to locate 1 by 2 in the middle of it. And similarly, the interval 0 to minus 1 is also divided into two equal parts, and minus 1 by 2 lies exactly in the middle of it. Similarly, there is another example of 1 by 8. In this, now I think you'll be able to guess that we need to divide the interval 0 to 1 into exactly 8 equal parts, and that will be a difficult job. So you'll use your ruler and divide it into exactly 8 equal parts. The first one is 1 by 8, then comes 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, and finally 8 by 8. And as you know, 8 by 8 is 1. So notice that 1 is being placed at the top of 8 by 8. Next, you need to represent minus 5 by 6, minus 2 by 11, minus 5 by 11, minus 9 by 11 on the number line. Now, if you look closely, minus 5 by 6 has to be represented on a separate number line, and the rest three can be represented on a single number line. Why? Because they all have a common denominator. So, for minus 5 by 6, since you know it's a negative rational number, so it lies on the left side of 0. So minus 1 by 6, minus 2 by 6, minus 3 by 6, minus 4 by 6, minus 5 by 6, and minus 6 by 6. So now if the denominator is 6, how many parts you need to divide it into? Exactly 6 equal parts. So now minus 6 by 6, as you know, is minus 1. So again, I've written minus 1 on the top of it. Now I need to represent minus 5 by 6. So what I'll do is I will encircle minus 5 by 6, as you can see in the number line. Similarly, I'll represent the rest 3 on the next number line. Again, minus 2 by 11, minus 5 by 11, and minus 9 by 11 are negative rational numbers. So again, they will lie on the left side of 0. You have 0, then you have minus 1 by 11, minus 2 by 11, which is being encircled. Why? Because it was asked to be represented. Next, minus 3 by 11, minus 4 by 11, minus 5 by 11, which is being encircled again, minus 6 by 11, minus 7 by 11, minus 8 by 11, minus 9 by 11, the last one to be encircled, minus 10 by 11, minus 11 by 11, and as you can see that minus 1 is being written on the top of it. Now you need to try to represent the following rational numbers on the number line. Minus 4 by 9, minus 16 by 9, minus 7 by 5, minus 3 by 11, 6 by 11, minus 8 by 22. But here's a question for you all. Can you guess which ones can be represented on the same number line? So if you look closely, the first and the second share the common denominator. So hence they can be represented on the same number line. What about the last three? So if you look closely, minus 8 by 22 can be reduced further, and it can be written as minus 4 by 11. Now, what you notice is that the last three will have common denominator as 11. So again, they can be represented on the same number line, and hence your task will be reduced. Now we'll be finding rational numbers between any two rational numbers. First of all, you should be sure that how many rational numbers actually lie between any two given rational numbers. So the answer is infinite rational numbers. There's an example here also. How many rational numbers can exist between minus 2 by 10 and 2 by 10? So with a surety, you can say that there are infinitely many rational numbers between them. Why? Because you can write minus 2 by 10 as, can you write it as minus 20 by 100? Yes. Can you write it as minus 200 upon 1000? Yes. So you can write it in infinite ways. So if you can write them as infinite ways, there can be infinitely many rational numbers between them. There's another example in which they have only asked you to give 10 rational numbers between 3 by 5 and 3 by 4. So the solution goes as follows. 3 by 5 is being multiplied with 20 and 3 by 4 is being multiplied with 25. Why is that so? So that the denominator remain the same. Okay, so if you multiply 3 by 5 with 20, you'll get 60 by 100, and 3 by 4 will become 75 by 100, and then you can find 10 rational numbers easily. What you can do is you can also find the LCM and then you can multiply it with 10 or 100 depending on the rational numbers being asked. Also, please keep in mind that you cannot include 60 by 100 and 75 by 100 in this list, okay, because it is strictly between these two. So keep in mind that you will not at all put these two rational numbers in the list. That will be wrong. Next, we come to exercise 1.2. We have already done exercise 1.1 of NCERT in the previous slides. Now, question 1 is to represent these numbers on the number line. The first is 7 upon 4. So it lies on the right side of 0. Now you have the number line showing it, and 7 by 4 is being encircled. Here in the second part, you need to represent minus 5 by 6. So that is also an easy job. Now you already know that it is a negative rational number, so it will lie on the left side of 0. So again, minus 5 by 6 is being represented and it is encircled. All right, next. We come to question number 3, in which you need to write 5 rational numbers which are smaller than 2. So the answer is quite easy, as you already know that 1, 0, 1 by 2, 1 by 3, 1 by 4, they are all smaller than 2. Question number 4 asks you to find 10 rational numbers between minus 2 by 5 and 1 by 2. So again, you can either find the LCM, multiply it with 10, or what you can do is you can multiply it with another number so that the denominator remains same, and you will easily get 10 rational numbers between them. But as I told you that you cannot include minus 8 by 20 and 10 by 20 in the list. That will be again wrong. In question number 5, you need to find 5 rational numbers between 2 by 3 and 4 by 5 in the first part. So if you solve them, you can easily find exactly 5 rational numbers between them. You can either take out the LCM and then multiply it with 10 or 100. Or what you can do is you can multiply 2 by 3 with 20 and 4 by 5 with 12 so that the denominator remains same and the numbers become 40 upon 60 and 48 upon 60, and you can easily find 5 rational numbers between these two numbers. Now in the second part, again you need to find 5 rational numbers between minus 3 by 2 and 5 by 3. So you can easily find them, and they can be minus 8 by 6, minus 7 by 6, minus 6 by 6, minus 5 by 6, and minus 4 by 6. But you obviously can't include minus 9 by 6 and 10 by 6. Be careful about that. In the third part, you need to find rational numbers between 1 by 4 and 1 by 2. Again, what we have done is we have made a common denominator of 32, and then you can easily find 5 rational numbers between 8 by 32 and 16 by 32. And don't forget to not include 8 by 32 and 16 by 32 in the list. Right? 5 rational numbers greater than minus 2. So if you look closely, minus 2 is the rational number which is given, and you need to find the rational numbers greater than minus 2. So by logic, you can say that minus 1, 0, 1 by 2, 3 by 4, 1 are the rational numbers which are greater than minus 2. Your answers can vary because you have infinitely many rational numbers which are greater than minus 2. So these are not the stipulated answers. You can have your own answers for these questions. Now, in question number 7, you need to find 10 rational numbers between 3 by 5 and 3 by 4. Okay, 3 by 5 and 3 by 4 are made into rational numbers with common denominators, which are 96 upon 160 and 120 upon 160, and then you can easily enumerate any 10 of them. Now, there are a few assignment questions. This is question number 29 of your assignment folder. Let's read the question first. One fruit salad recipe requires 1 by 2 cup of sugar. Another recipe for the same fruit salad requires 2 tablespoons of sugar. If 1 tablespoon is equivalent to 1 by 16 cup, how much more sugar does the first recipe require? So, for the first fruit salad recipe, you need half a cup of sugar. Now, for the sugar, for another salad, they have given us an equivalency in the question. So, 1 tablespoon is 1 by 16, but the recipe required how many tablespoons? 2. So, what you'll get is 2 into 1 by 16, which becomes 2 by 16. Or you can also write this as 1 by 8. Now they have asked you how much more sugar was required in the first recipe. So what you'll do is you'll subtract 2 by 16 from 1 by 2. After taking the LCM, you'll get this as 6 upon 16. When reduced, this becomes 3 by 8 of a cup. Now this is question number 33 of your assignment. On a winter day, the temperature at a place in Himachal Pradesh was minus 16 degrees Celsius. Convert it in degree Fahrenheit by using the formula C by 5, where C stands for Celsius, is equals to F minus 32 upon 9, where F stands for Fahrenheit. Now the temperature was minus 16 degrees Celsius. What you'll do is you'll put the value of minus 16 at the place of C. Simply, you'll get the equation as minus 16 upon 5 is equals to F minus 32 upon 9. Now, you already know how to solve simple equations that you've done in class 7th. So, what you'll do is you'll easily multiply 9 over here. It becomes minus 144 upon 5, and what remains is F minus 32. And now you obviously know how to transpose minus 32 on the RHS. What you do, minus becomes plus. So F is equals to 32 minus 144 upon 5. If you take the LCM and try to solve it, it will come out as 16 upon 5, which is equal to 3.2 degree Fahrenheit. Now you have another question. Huma, Hupna and Seema received a total of 2016 as monthly allowance from their mother, such that Seema gets 1 by 2 of what Huma gets and Hupna gets 2 by 3 times Seema's share. How much money do the 3 sisters get individually? So now Seema gets allowance 1 by 2 of Huma's share, and Hupna gets 2 by 3 of Seema's share. Now, you already know from the first statement that Seema's share is 1 by 2 of Huma. You can easily get this as 5 by 6 of Huma's share. Now, from the statement given in the question that the total amount they have received is what? 2016. So now you can form the equation, and what you get is Huma's share plus Hubna's share plus Seema's share, and the total becomes 2016. Huma's share will be kept as it is, and we know that Hubna's share is what? 5 by 6 times of Huma. So you'll write Hubna's share as 5 by 6 times of Huma's share. Similarly, you know that Seema's share was, if you see here, it was half of Huma's share. So you'll put half of Huma's share here. Now, if you add them, you'll take the LCM and you'll get 14 upon 16 of Huma's share is equals to 2016. If you solve the equation, you'll get this as rupees 864. But if you look at the question carefully, it has actually asked to find how much money do the three sisters get individually. And we have only found Huma's share right now. So what two are still remaining to be found? Hubna's share and Seema's share. Seema's share is half of it, hence it is rupees 432, and the other sister has rupees 720. So now I have enlisted that these three sisters have got these many rupees individually, respectively. Now you have question number 2 of the assignment folder. Roller coaster at an amusement park is 2 by 3 meter high. If a new roller coaster is built, that is how much times the height of the existing coaster? 3 by 5 times. And you simply have to find the height of the new coaster. So if you look, what is the height of the existing roller coaster? 2 by 3 meter. You can easily find the height of new roller coaster, which will be 3 by 5 times of 2 by 3. So if you multiply, I hope you remember how do we multiply two rational numbers. It was done in class 7th. So what you can do is either I can multiply the numerators together and the denominators together, or I can make my calculations easy by cancelling 3 from the denominator and 3 from the numerator here, and I can simply get 2 by 5 meter. So height of the new roller coaster is 2 by 5 meter. Now, there are few assignment questions that you need to do, and please prepare a notebook for your assignment questions which are given in the videos in the previous part as well as in this part. So you'll make this notebook and you'll keep a track of all the questions which will be checked later on. Question number 14. Subtract the additive inverse of 5 by 6 from multiplicative inverse of minus 5 by 7 into 14 by 5. So you'll multiply these two first and then you'll subtract the additive inverse from that. What is the additive inverse? The negative of 5 by 6, which will be minus 5 by 6. The answer has been given here, so you can easily recheck the answer. Insert 6 rational numbers between these two parts. Now you can obviously easily find them and your answers can vary. Now in question 16, you need to multiply the reciprocal, and I hope you know the meaning of reciprocal, multiplicative inverse. It will be 11 by 9. From the additive inverse of minus 18 by 55, which will be 18 by 55, and hence you'll get 2 by 5. You need to verify commutative property under addition. I hope you know commutative property in which we change places. So A plus B will be equal to B plus A. You need to verify it. Now in 18th question, what should be added to minus 9 by 7 so that the sum becomes its multiplicative inverse? What is the multiplicative inverse of minus 9 by 7? It will be minus 7 upon 9. Since you know that minus sign remains in the numerator, the answer has been given. You can easily verify your answer. Question number 19. By what number should this be divided to get minus 5 by 7? And you can easily verify your answer. It will be 3 by 8. There is homework from NCERT as well. question number 2 of the second exercise, and example 6 to 9. So now I really hope that you'll be regular with the homework. I'll definitely upload part 3 after this, in which we'll cover NCERT exemplar questions, and I'll give you a lot of other questions, a lot of important questions for practice. Thanks.